Hey everyone, and welcome to this explainer. Today, we are taking a seriously fascinating cosmic road trip, heading way outward through our solar system. We're going to venture far beyond the familiar, charting a course into the hidden worlds that orbit our sun. So buckle up. We are heading into the dark, icy, and honestly incredibly dynamic regions of our cosmic neighborhood to uncover the amazing stories of the dwarf planets.
Right off the bat, I want to pose this question directly to you. What actually lies beyond the 8 traditional planets? For a long time, our map of the solar system felt completely finished, neatly wrapped up by Neptune and, of course, Pluto. But as our telescopes and tech have improved and we've peered deeper and deeper into the dark, well, we've realized that traditional view is literally just the beginning. There are massive disks of icy debris, shattered remnants of cosmic collisions, and entire undiscovered worlds out there that challenge our very understanding of what a planet actually is. Here is our flight path for today. 1. Beyond the 8 planets. 2. Ceres and the Asteroid Belt. 3. Entering the Kuiper Belt. 4. Pluto's icy realm. 5. Haumea and Makemake. And finally, 6. Eris and the scattered disk. Okay, Section 1. Beyond the 8 planets.
Before we can really appreciate the strange and beautiful dwarf planets we're about to visit, we absolutely need to understand the cosmic rulebook. What exactly separates a true planet from a dwarf planet? Well, to be in the full-fledged planet club, a celestial body has to satisfy 3 very strict criteria. First, it's got to orbit the sun. Simple enough. Second, it must have enough mass, and therefore enough gravity, to pull itself into a nice spherical shape. And third, it must be gravitationally dominant enough to clear its neighborhood. Basically, that means it has dislodged or swept up other objects of similar size in its orbital path. And as you'll see, it's this tricky third rule that creates our fascinating cast of rule breakers, the dwarf planets.
Section 2. Ceres and the Asteroid Belt.
Our cosmic road trip makes its very first stop right here in the inner solar system. We don't even have to leave the rocky planets behind to find our first dwarf planet. To find it, we navigate straight into the asteroid belt. Think of this as a vast spinning disk of rocky and metallic debris located right between the orbits of Mars and Jupiter. It's essentially a massive storehouse of cosmic history, filled with millions of rocky fragments that just never quite managed to coalesce into a full planet.
If you look at our location relative to Earth here in the inner solar system, the asteroid belt forms a very distinct boundary before we reach the massive gas giants. And, while it might look like a chaotic, crowded bumper car arena in sci-fi movies, space is actually incredibly vast. But right in the middle of this scattered debris field sits the undisputed king of the asteroid belt.
Meet Ceres. Spotted all the way back in 1801, Ceres is the smallest of the known dwarf planets, measuring about 950 kilometers wide. But please don't let its size fool you. Ceres alone is responsible for nearly a third of the mass of the entire asteroid belt. It's the only dwarf planet located in the inner solar system, and because it sits smack dab in the middle of this debris field, it naturally fails that third rule of clearing its neighborhood. It's a completely bizarre world. It has low gravity, kind of like our moon, a super thin atmosphere, and incredible features like glowing bright spots of salt and actual cryovolcanoes on its cratered surface.
But here is the most absolutely staggering fact about Ceres. Scientists believe it has a rocky core surrounded by an icy inner mantle that is 100 kilometers thick. And calculations suggest this mantle may contain up to 200 million cubic kilometers of water. Stop and think about that for just a second. This tiny little rock floating out between Mars and Jupiter likely holds more fresh water than can be found on all of planet Earth. That is just mind-blowing.
Section 3. Entering the Kuiper Belt. Leaving the surprising, watery depths of Ceres behind, we're now firing our engines and warping to the freezing, incredibly dark outer edges of our solar system, way out past Neptune. We have officially entered the Kuiper Belt. Think of this as the solar system's third zone. Unlike the rocky asteroid belt we just left, the Kuiper Belt is a massive disk primarily made of icy objects and comets. It contains thousands of frozen, almost fossil-like remnants from the very dawn of our solar system, all in a totally wild variety of different shapes, colors, and sizes. The Kuiper Belt forms a massive ring on the very edge of our solar system's map. It's dark, it's unbelievably cold, and sunlight out here is incredibly faint. But what iconic, deeply beloved celestial body actually calls this freezing, distant neighborhood home? Section 4, Pluto's icy realm.
That brings us to our most iconic dwarf planet, a world that has totally captured our imaginations since it was first discovered back in 1930. For decades, Pluto enjoyed the prestigious status of our ninth planet. But remember those 3 rules of the Planet Club we talked about? Well, Pluto definitely orbits the sun, and it definitely has enough gravity to be wonderfully spherical. But it sits squarely inside the incredibly crowded Kuiper Belt, surrounded by thousands of other icy bodies. Because Pluto hasn't cleared its orbital neighborhood, its status was officially changed in 2006 to Dwarf Planet. But as we've already learned, being a dwarf planet absolutely does not make a world any less complex or dynamic. And this brilliantly illustrates that exact point. Pluto is far from alone out there in the dark. It actually possesses a highly intricate system of 5 known moons. The largest is Charon, which is so massive relative to Pluto that they literally orbit each other like a binary system. Then you have smaller moons like Nix, the 3rd largest, and Hydra, the farthest one out. It's basically a bustling mini-system sitting billions of miles away from the sun.
Section 5. Haumea and Makemake.
Now, what's really interesting here is Haumea's highly unusual, elongated shape. Discovered in 2004, it looks less like a classic round planet and way more like a cosmic egg, or maybe a smoothed river stone. Why? Well, because Haumea is one of the fastest rotating objects in our entire solar system. It completes a full spin on its axis once every 3.9 hours. That blistering rotational speed actually stretched the rocky, ice-coated dwarf planet out into this flattened, elongated shape. Scientists believe Haumea was born from a massive collision billions of years ago, a crash that also gave it 2 small water ice moons, Hyakka and Namaka.
To truly grasp the wild diversity of the Kuiper Belt, just look at this comparison between Haumea and its neighbor, Makemake. While Haumea has a frantic, dizzying 3.9-hour day and 2 moons, Makemake takes a much more leisurely 22.5 hours to complete a single rotation, and it just has 1 tiny, recently discovered, currently unnamed moon. But when it comes to their actual orbits around the sun, Makemake is incredibly slow. A single year on Makemake takes a staggering 306 Earth years to complete.
Visually, Makemake is really distinct as well. It's actually the 2nd brightest known object in the outer solar system right after Pluto. It has this notable reddish hue and is shrouded in a very thin atmosphere made of methane and nitrogen. It's also so incredibly far away that sunlight takes 6 hours and 20 minutes just to reach Makemake. And the faint light we see from it through our telescopes, that takes over 7 hours to travel all the way back to Earth. Section 6. Eris and the Scattered Disk. For our final destination, we are pushing to the absolute limits of our journey, moving out into a place so remote it almost defies comprehension. We are now in a chaotic, icy region of space known as the Scattered Disk, and residing right here is Eris. When Eris was first discovered, its highly reflective surface, which we believe is composed of nitrogen-rich ice mixed with frozen methane, shone so brightly that astronomers initially assumed it was actually larger than Pluto. While we know today that Pluto is slightly larger by volume, Eris holds the crown as the most massive of all 5 recognized dwarf planets. It's a heavy, rocky world sitting at the absolute furthest, coldest edge of our solar system's gravitational reach. Okay, before we wrap up our cosmic road trip, let's shift our focus and bring things back toward home. Because you see, what happens in these super distant regions like the asteroid belt and the outer disks doesn't always stay out there. Sometimes, shattered debris from cosmic collisions breaks free from its orbit and heads right our way. Caught by Earth's gravity, these space rocks hurtle toward us. When they hit our atmosphere and burn up, creating a beautiful flaming streak across the night sky, we call them meteors. So the crucial point here is the difference in terminology. If that piece of ancient cosmic debris actually survives the violently hot, burning trip through our atmosphere and successfully lands on the surface of the Earth, it earns a brand new title, a meteorite. These dark, heavy stones are literally pieces of the asteroid belt, or occasionally other celestial bodies, delivered directly to us, allowing our scientists to study the fundamental building blocks of our solar system with their own 2 hands. We've traveled from the shocking, watery depths of Ceres to the rapidly spinning cosmic egg of Haumea, all the way out to the massive, icy world of Eris in the scattered disk. But honestly, the most exciting takeaway from this explainer is that space is just incredibly vast, and there is still so much out there we haven't found yet. If Eris and Makemake were only discovered within the last couple of decades, it leaves us with a truly profound question.
What other bizarre, completely undiscovered dwarf planets might still be lurking out there in the darkest, unexplored edges of our solar system, just waiting for us to find them?